Welcome to video 3 under moles in the formula mass, moles, and stoichiometry unit for Chemistry 1. In the last video, we looked at a gram to mole example problem, and I gave you the general formula. I asked you to try these two at your seats, and then we can go through how these are calculated. So in the first problem, how many moles are in 49.0 grams of sodium chloride? We underline what we're given. 49.0 grams of sodium chloride that has a formula of NaCl, and we're looking for moles. So we start with what's given, 49.0 grams of NaCl, and we draw our little conversion chart. So we need to come up with our conversion factor, which is 1 mole of anything is equal to the formula mass of that substance. So we need to find the formula mass for NaCl. So Na is 22.99 and chlorine is 35.45, and we have one of each. So when we add those two together, we get 58.44 grams. So remember that is how many grams are in 1 mole. So if we look at our general formula, the given number of grams goes in this spot. The formula mass goes down here in the bottom. So our formula mass we calculated was 58.44 grams of NaCl. Up on top is our 1 mole, because 1 mole is equal to this number. So we're in essence multiplying 49.0 by 1. But we're changing the units, which is why this is called a unit multiplier. So 1 mole of NaCl. So our units of grams cross out, and we're left with moles of NaCl. So we have to worry about significant figures. And if you look, 49.0 has 3 significant figures, and our formula mass has 4. So we always report to the lowest number. So I'm just going to put 3SF for 3 significant figures. So now all we have to do in our calculator is put 49.0 divided by 58.44, and we get 0.838466804. Well, we have to round that to 3 significant figures. So remember that 0 in the front doesn't count, but 8 would be our first. There's our second. There's our third, and we have to make sure that the next number past that doesn't bump up that 8. It's a 4, so it doesn't. So 0.838 is our answer. And make sure that you have all of these units and labels on everything, including your answer. That is important. Let's look at our second example. I gave you the formula for carbon disulfide as CS2. And we're given 2.085 times 10 to the minus 2 grams. So it's in scientific notation. And we're looking for moles. So here is another gram to mole problem. We always start with what we're given. 2.085 times 10 to the negative second grams of CS2. Now you could change that to 0.02085 grams if you didn't want it in scientific notation, but you don't have to. So now we need the formula mass for CS2. Well, there's 1 carbon and it's 12.01, and there's 2 sulfurs and each one is 32.07. So when we add those together, we get 76.15 grams. So that's how many grams are in 1 mole of CS2. So following our general formula, we have the grams given. Now down here we put the formula mass, which we just calculated to be 76.15 grams. And up on top, we put 1 mole of that substance. Our grams cross out. We divide. And remember in our calculators, when we have scientific notation, we use an EE button. So 2.085 second EE on this calculator minus 2. That little E right there in the calculator stands for times 10 to the. and then we divide it by 76.15. And we get this really small number. Now, it's fine to report it to the correct number of significant figures, or we can put it in scientific notation. It doesn't matter, they're the same number. So, we need 4 significant figures. 2.085 times 10 to the minus 2 is 4 significant figures. 76.15 has 4, so 4 is our least number. So these zeros in front don't count, so 2, 7, 3, 8 are our 4 significant figures. We look one past there, that 0 does not bump that 8 up to a 9, so we end up with 0.002738 moles of CS2. Now, if you wanted to put that in scientific notation, we'd have 2.738 times 10 to the negative 4th moles of CS2. Either one is absolutely correct. That's the end of this video.